All right, let's talk about gold. One of the most sought-after elements on the entire planet. But the real story here? It's probably not what you're thinking. It's actually this incredible tale of alchemy, but the alchemist is, well, it's Earth itself.
So, the first question that probably pops into your head is, why is gold so valuable? I mean, it seems obvious, right? It's beautiful, it's super rare, and for literally thousands of years, it's been the symbol of wealth. But what if I told you that's the wrong question to be asking? What if the real secret of gold is buried somewhere much, much deeper?
Yeah, seriously. To really understand gold, we've got to flip that whole question on its head. Because asking why it's valuable, that completely misses the real story, this amazing geological drama that has to happen first. So we shouldn't be asking why it's valuable. We should be asking,
Yeah, that's the real puzzle. See, here's the wild part. Gold is actually rare everywhere. It's just spread out. It's sprinkled super, super thinly throughout the Earth's crust. So the real miracle isn't that gold exists. The miracle is finding enough of it in one place to even matter. The real story here is the story of concentration.
okay, so this word concentration, this is the key to everything we're going to talk about. Just think about it. Nature has to pull off this amazing magic trick, right? It has to take these countless invisible gold atoms that are scattered across like cubic kilometers of rock and somehow gather them all up into one spot, into veins that you can actually see. So this whole story isn't about creating gold. It's about collecting it.
So how in the world does nature grab onto something so elusive? Well, it turns out gold's secret weapon is its personality. It's just incredibly stubborn. You could even say it's antisocial. It doesn't rust. It doesn't really dissolve easily. It pretty much refuses to team up with other elements. And because it's so chemically aloof, it can survive these epic, world-shattering geological events that just pulverize and destroy everything else around.
All right, so where does this whole concentration process kick off? Well, it starts miles and miles beneath our feet, where heat and water begin the planet's first incredibly slow sift of those individual atoms.
Okay, try to picture this. You've got superheated water under just immense pressure, and it's forcing its way through all these deep cracks in the Earth's crust. This water acts like a ghost train for gold. It actually dissolves and carries these invisible gold atoms, basically snatching them right out of the surrounding rock. But as that water travels up and starts to cool down or lose pressure, it can't hold on anymore. It loses its grip. The gold can't stay dissolved, so it precipitates, that's the sciencey word for it. It literally falls out of the water and starts sticking to the walls of the cracks, usually right alongside its good buddy quartz.
Here's a great way to think about it. Imagine the Earth's crust is just a giant pot of soup. And gold? Gold is like a spice that's been sprinkled all through it. It's there, but it's so spread out you can't taste it. Well, that whole hydrothermal process is like simmering the soup for eons. The heat and the water slowly concentrate that flavor, gathering all that spice into one place. And that's how you get these rich veins of gold. That's how the first lode deposits are born.
But you know what? Forming those veins deep underground, that's only half the story. For us humans to ever actually find the stuff, it has to get to the surface. And that journey, it needs a second, even slower sift. One that's driven by the incredible power of erosion and gravity, playing out over millions and millions of years.
So let's zoom out to a geologic timescale. Think about it. Entire mountains shot through with these gold and quartz veins are slowly pushed up. Then, over thousands, even millions of years, nature just goes to work. Wind, rain, rivers, they just relentlessly grind these mountains down. The rock, even the super hard quartz, gets pulverized and washed away. But that stubborn gold, once it's freed from its rocky prison, it just endures. It doesn't change.
And this, right here, brings us to that classic image, the old prospector swirling a pan in a river. It's not just about luck. There's a fundamental law of physics at play here, a specific property of gold that makes this whole second sorting process even possible. So what is it?
It all comes down to this one number, 19. Gold is 19 times denser than the water trying to carry it. And that changes absolutely everything. So this is the final sorting in action. Look at this. A river current can easily push around sand and mud, right? They're only about 2.5 times denser than the water itself. But gold, at 19 times the density, it's just no contest. The second a little piece of gold is free, it drops like a rock. Gravity just takes over completely. The river becomes a giant, natural sluice box, separating the heavy gold from all the light stuff, leaving these amazing little trails of concentrated placer gold behind.
So you've got these two incredible sifting processes, one after the other. And when you put them both together, what you get is a recipe for true, mind-boggling rarity. You really start to see why finding a rich gold deposit is one of the most unlikely events on the entire planet.
It really is like a cosmic recipe, and the ingredient list is just impossibly long. First, you need intense heat and pressure, deep inside the Earth. Then you need a massive plumbing system of hot, circulating water. You need a whole network of cracks and faults for that water to move through. You need exactly the right kind of rock chemistry. You need millions, sometimes hundreds of millions of years for it all to just cook. And then, after all that, you still need millions more years of erosion to bring it all to the surface and start the sorting all over again.
And here's the kicker. You miss just one of those conditions. Not enough heat, the wrong rocks, not enough time, and the whole process just fails. The concentration never happens. And the gold, it just stays where it was, as invisible dust, scattered and completely forever out of our reach. And this, right here, is the single most important idea I want you to take away from all this. Gold isn't valuable just because the element itself is rare. It's valuable because the process that gathers it all together is so unbelievably, mind-blowingly rare. Every single gold deposit we find, it's like a winning lottery ticket against cosmic odds.
So let's end on a final, quieter thought. The next time you see a piece of gold, a ring, a coin, anything, just take a second to think about the insane journey every single one of its atoms has been on. Just really think about that for a second. Every gold ring on someone's finger, every old coin, every tiny fleck you see in a museum, it all started its journey as individual atoms, totally invisible, dissolved in superheated water, flowing through the dark cracks of the Earth's crust, kilometers beneath your feet.
Because in the end, mining doesn't create gold. Not at all. We're more like geological archaeologists. We're just finding the very few, very special places where our planet already did all the hard work for us, where it performed this incredible feat of alchemy over millions of years, patiently sifting and sorting and gathering this stubborn, beautiful element, just waiting for someone to come along and find it.